We're live! Yay! This is Math 60 Intermediate Algebra. We're in Chapter 9. We're talking about logarithms. We're having fun. We're talking about mathematics in Scotland in the 1500s. We're talking about common logs and natural logs. So what the heck are we talking about here? Well, there are two logarithms that come up a lot in math. The first one's called common log, and we shorten it just by writing log. You'll notice there's no little base down there. It means base 10. Now, I wonder why base 10 would be the standard. So base 10, because we all started counting on our fingers and toes, and which interesting, some groups of folks ended up with base 20 because of that, which is interesting. But a lot of math is done with base 10 because of 10 fingers, including the thumbs. So that's called common log, and you'll see it on your calculator. Well, right there, it just says log. Now, if you ever forget which base it is, if you look right above it, it says 10 to the x, because these two are the best buds. These are those two long lost evil twins, right? Okay, so that's one of them. The other one's called natural log. Now, you remember I gave that little book report on the letter E. Log base E is written, and let me point out, this isn't IN, it looks like it. It's LN. It's LN for log, naturel, right? Naturel. Okay, I'm having trouble with my French tonight. Sometimes my throat just doesn't want to be French. So there's my natural log, ln, log naturel. And there's e to the x right above there. So you can remember these two are best buds, e to the x and natural log. So these two are used so much more than any of the other logarithms. That's why you get them on your calculator. Almost every scientific calculator has a key for log and a key for natural log. Now, if you've got a cheap one like I do, this is an older one, so it's pretty inexpensive. You'll notice there are no other logarithms on it. There are some calculators nowadays that have a lot more logarithms you can use. You can choose your base. So it really depends on what calculator you have, but the two you really need are common log and natural log. Okay, so let's work with common log and natural log a little bit. So you just have to remember what they are. So if I just say plain log of x equals 5, you have to know, oh, this is actually log base 10 of x equals 5. And then we do the conversion thing. Remember the conversion dance? You start down low on the left, and you go around counterclockwise, make kind of a little spiral there. 10 to the 5th equals x. So that means x equals, that's 10 to the 1st, 2nd, 3rd, 4th, 5th. 100,000. Woohoo. 1, 2, 3, 4, 5. 5 zeros. Remember, this is a little bit like scientific notation. Kind of reminds you of scientific notation. Logarithms are used for keeping track of very large things like earthquakes or like sound levels. So you use logarithmic scales for earthquakes, for sound levels, and interestingly enough, also for pH. So if you're actually talking about whether something's a base or an acid, you're using logarithms. It's kind of cool. Okay, we move on. Oh, I didn't put a box around it. Next one. And I know it looks IN. It's not IN. If you have this, it's ln x equals 3. Natural log of x equals 3, which means you've got log base e of x equals 3. Start low, move around in a spiral. E cubed is x. Now, I didn't specify whether I wanted you to give an exact answer or an approximate. So this would be the exact answer. Or on my calculator, remember, I go up above natural log to get my e to the x. E cubed is It's about 20.1 if I round to one decimal place. So depends on whether I wanted an exact answer or an approximation. Okay, number 3. Ooh, can logarithms be negative? And the answer is the answer can be negative. The question cannot be negative. The domain of a logarithm has to be positive, and it has to be greater than 0. So let's look here. Log. So if I have plain log of x equals -2, then what I really have is log base 10 of x equals -2. So again, I do my little spiral. 10 to the -2 equals x. X equals 10 to the -2, which is, what is that? 1 over, right? Because it's a vampire. That's 1 over 100. Where's my vampire? Blah, blah. Ha, ha, ha. So if I've got a, remember, if you've got a negative exponent, it means you like to live downstairs. You want to live in the crypt in the basement. Ha ha. So we bring the 10 to the -2, we bring it down into the basement, 10 squared, and that's 1 over 100. Okay, so what would x have to be to get -2? X would have to be 1 over 100. Shall we do one more? Yes, let's do one more. Okay. Now this one I wrote backwards. I'm not sure why I wrote it backwards that way, but let's go with it. X equals log of 0.001. So this is log base 10 of 1/10, 100th, 1,000th. So this is 1 over 1,000. So we're working this one. Log of 1 over 100 was what? -2. So what is this going to be? This is log base 10 of 1 over 10 cubed. So that means it's log base 10 of 10 to the -3rd. So how many 10s are there? There are -3 10s. How many 10s are there in 1 over, how many 10s multiplied together make 1 over 1,000? 10 to the -3rd power makes 1 over 1,000. Kind of woohoo? Kind of a little bit. I know this is all brand new, so if you've never heard of this before, this is just going to be kind of wild and kind of weird. What should we do next? Oh, I don't know. When you don't have anything else to do, you should graph. So I printed out a graph, but I also have my handy dandy Desmos. So let's take a look. And I've got almost 4% on my tablet, so things are good. First off, you know me. I have to write in the arrows. Okay, thank goodness. None too soon. So this is the graph of e to the x. This is the graph of natural log of x. What do you notice? And since this is paper and this is a video, I can do what I can't do in class, which is if I fold, and I didn't fold it all that well. But if I fold kind of along this line, this is the line y equals x. If I fold along this line, what do you notice about the graph of e to the x and natural log? Is they're symmetric around or about this line. Remember, mathematicians say about when they mean around. It's a thing. So there's symmetry about the line y equals x. So this means around. It's just the way we say it. This one goes, so natural log of x. The domain seems to me to be x is greater than 0, right? And the range? This seems like it's heading down. And it seems like, now this is kind of going up very slowly, but it looks like it would be going up as far as, I mean, it'll just keep going up. It'll just take a long time. So I would guess this would be all reals. That would be interesting, right? Okay. What was e to the x? Do you remember the rules about e to the x? The domain was all reals. You can put anything you want into it. And what comes out? What comes out is it stays above the x-axis. I'll write the x and the y in there. And so the range is that y has to stay positive. Notice how the domain and the range flipped for these two. Also, for e to the x, where's the asymptote? The asymptote is the x-axis. There's just no end to all the letters in that word. I just don't even understand it. Now tell me about natural log. Natural log seems like it has an asymptote, but the asymptote is going to be the y-axis. Do you notice that pretty much everything feels like it just swapped? It swapped places. That's exactly what happened. Now, if you're wondering, well, I wonder if 10 works the same way. Well, I happen to have this. So let me get this guy into position and then turn off the light so you don't all get, blinded by the bright light. The red is 10 to the x. There's our exponential function. Here's our logarithmic function. Now, I can't fold a tablet, but if you could imagine a line right here, straight through the middle, do you see that there's that symmetry here? Do you see that there's the exponential has an asymptote along the x-axis and the logarithm has the asymptote along the y-axis? It's kind of cool, huh? So logarithms and exponentials, it's just all we did was we swapped x and y. So we're talking about when we talk about natural log or we talk about log, any logs, we're really just talking about exponentials. But for whatever reason, we're having trouble getting at the exponentials. And so we're going to talk about them by using logarithms. Woohoo! This is very exciting. Woohoo! We did it. We finished the introduction. The next section is going to be some other weird, really weird things you can do with logarithms. Okay, math on.